Okay, so the second derivative test says if the f prime of c equals 0 and f double prime of c is positive, then the function has a local minimum at x equals c. Right. So f double prime is positive, the graph concave up, and the f prime of c equals 0, we have a horizontal tangent line. So at this critical point, function has a local minimum. And if f prime of c is 0 and f double prime of c is negative, then the function has a local maximum at x equals c. Because if the second derivative is negative, the function concave down. And at c, if we have a horizontal tangent line, so the function gonna have a local maximum. Okay, then let's try this example using this method. Here we want to find the local maximum and minimum of the function f(x) equals 3x to the fourth minus 4x to the third minus 12x squared plus 5. So we first take the derivative of this function, and then we find from the derivative we can find the all the critical points. Okay. Because this function is a polynomial function, therefore it exists everywhere. So to find the critical point, we can only find them by solving for this equation. This is a polynomial equation, and we notice that each term has a common factor, which is a 12x. So we factor that out. Okay. So we can have 12x times x squared minus x minus 2 equals 0. And we can also factor this trinomial into x minus 2 times x plus 1. So there are three solutions. There are three zeros for this equation. Okay. Since all of them are in the domain of the function, so all the 3 points are critical point. Okay, to use the second derivative test, next we take the derivative again, so we can have the second derivative. So the second derivative is 36x squared, and minus 24x and minus 24. Okay, now next we plug each of these 3 points into the second derivative. If the second derivative is positive at those points, that means the function gonna have a local minimum at that point. If the second derivative is negative, then the function gonna have a local maximum at that point. Okay, so let's start with the 0. At x equals 0, the second derivative is 36 0 square minus 24 0 minus 24. So it's negative 24. Therefore, according to our result, the function has a local maximum at x equals 0. Right? Because the first derivative at 0 equals 0, and the second derivative at 0 is a negative. So the function has a local, function gonna have a local maximum. So it looks like this. Okay. Then at x equals 2, the second derivative is 36 times 2 squared minus 24 times 2 minus 24. And this is 36 times 4 minus 48 minus 24. So that's 144 minus 48 minus 24. Now, this result is positive. Because it's positive, the function has a local minimum at x equals 2. Okay, lastly, at x equals -1, the second derivative is 36 times -1 squared minus 24 times -1 minus 24. That is 36 plus 24 minus 24. It's positive. Okay. So the function has a local minimum at x equals -1. Okay. So according to the result, according to the second derivative test, the function has a local maximum at 0, and it has a local minimum at x equals 2 and x equals -1. Let us verify this result. Minus 12x squared plus 5. Now we can see the maximum, it occurs when x is 0, right? When x is 0. And the minimum, it occurs when x equals -1. And another minimum, it occurs when x equals 2.